Hi, I'm Ms. Hearn. Let's get started. In this video, we're going to solve a rational equation. This is one of the more challenging problems in an intermediate algebra class. It requires a lot of steps, and we're going to go through those steps one at a time. But first, let's just talk about how we know that this is a rational equation. So we have -5 over w plus 2 equals -6 plus 2 over w plus 1. It's an equation because we have that equal sign. And notice we're being asked to solve for w. That means we're looking for numbers that would make this statement true. It's a rational equation because it has fractions with variables in them. And whenever you see that you have a rational equation, there are a couple main things to keep in mind. First, you have to be careful because the variable is not allowed to be any numbers that would cause those denominators to equal 0. So we're going to have to find these restricted values that it's not allowed to have as a solution, and keep those in mind. Second, we're going to have to find the least common denominator and multiply it on both sides of the equation to get those denominators to cancel out. Nobody likes fractions, but the good news is whenever you have fractions in an equation, we have ways of getting rid of those fractions. So here we go. The first step is to look at your denominators and see if they need to be factored. In this case, we have two linear expressions, w plus 2 and w plus 1. There's no w squared or w cubed. That's what I mean by linear. And there's no factor in common to the two terms in either case. So there's nothing to factor out. Moving on to step 2, we're going to find the least common denominator of any fractions in the expression. And basically, if all the denominators are completely different factors, then all you have to do is multiply them together to get that least common denominator. So in this case, it would be w plus 2 times w plus 1. If there's any overlap, like let's say it had been w plus 1 times w plus 2 and w plus 1 times w plus 3, then the LCD would be a little bit different. You would not just multiply all four of those factors together because you only need the w plus 1 to appear once, since it only appears once in each denominator. So in that case, your LCD would have one of the w plus 1s and a w plus 2 and a w plus 3. So again, if the denominators are completely different, you just multiply them together, but if they have any factors in common, you only need to list those as many times as they appear in any one denominator. So let's go back to our original problem here. We're going to have our LCD w plus 2 times w plus 1. Now, what are we going to do with that LCD? Well, we're going to do two things. We're going to find the restricted values with it, and we're going to multiply it on both sides. But first, let's start with finding the restricted values. Since the LCD includes all the factors that appear in any of our denominators, those factors are not allowed to equal 0. So set each factor of your LCD equal to 0 and see what values of w we're not allowed to have in our solution. In this case, w is not allowed to be -2 and w is not allowed to be -1. These are our restricted values, and you want to keep these in mind because at the end, sometimes the process of solving the equation will try to trick us into thinking those can be solutions. So you have to compare to these at the end. So we're going to save these, and we're going to now use the LCD to solve the equation. The LCD, remember again, was w plus 1. Okay, so we're going to multiply w plus 1 times w plus 2 on both sides of this equation. And the effect that that's going to have is that we're going to distribute it to each term. And when the terms are fractions, it's going to end up in the numerator of the fraction. And the reason for that is because when you multiply a whole number times a fraction, you think of it as being over 1, and you multiply the top times the top, bottom times the bottom. So on the left, we're going to have -5 times w plus 1 times w plus 2 over w plus 2. And on the right, we're going to have negative 6 times w plus 1 times w plus 2 plus 2 times w plus 1 times w plus 2 over w plus 1. Now the reason we multiply on both sides by the LCD instead of using the LCD to get common denominators for all the fractions is because we see the next step getting rid of all of the fractions that were in the equation, which makes things easier for us. On the left side, w plus 2 divided by w plus 2 is just 1. And on the right side, w plus 1 divided by w plus 1 is just 1. So we're left with negative 5 times w plus 1 equals negative 6 times w plus 1 times w plus 2 plus 2 times w plus 2. Now at this point, we don't really know if we have a linear equation or a quadratic equation until we multiply through any parentheses and combine like terms. On the left, distributing the negative 5 gives us negative 5w minus 5. On the right, we have a little bit more work to do. I'm going to distribute the negative 6 to the w plus 1, which gives me negative 6w minus 6. And then I need to multiply that times the w plus 2. Don't make the common error of thinking you have to distribute the negative 6 to both of the sets of parentheses. Now we're going to FOIL, which means multiply the first terms together, then the outer terms together, then the inner terms together, and then the last terms together. So first times first would be negative 6w times w, or negative 6w squared. Outer times outer would be negative 6w times 2, which is negative 12w. Inner times inner would be negative 6 times w, which is just negative 6w. And last times last would be negative 6 times 2, which would be negative 12. Combining like terms, we have negative 5w minus 5 on the left. On the right, we have negative 6w squared, and we're going to combine negative 12w minus 6w is negative 18w minus 12. At this point, we can determine if we have a linear or a quadratic equation. Quadratic means that it has the highest power on the variable as a 2. Linear means that there are no powers on the variable. So we definitely have a quadratic equation. So step 8 depends on if we have a linear or quadratic. Since we have a quadratic, we have to use factoring or other quadratic methods to solve. In particular, in this case, I'm going to try to get the quadratic equation into what's called standard form, which means 0 on one side. Since I prefer to always have a positive coefficient in front of the squared term, because that makes factoring easier, I'm going to actually move all of the terms on the right over to the left-hand side. I'm going to do this by adding 6w squared to both sides, adding 18w to both sides, and adding 12 to both sides. The result on the left side will be 6w squared plus 13w plus 7. And on the right, all of the terms add up to zeros. So now we have standard form. There are a variety of ways to factor trinomials, which is the next step that we need to do in order to solve this equation. In my class, we use splitting the middle term, which is the AC method. You might use another method, but here I've split the middle term and I'm going to use grouping. And the result is that we have 6w plus 7 times w plus 1 equals 0. Now we're going to use the zero product rule, also known as the zero factor property, which tells us if two mystery numbers, which we have two mystery numbers here, are multiplied together and give us 0, then one of them had to be 0. So either 6w plus 7 is equal to 0 or w plus 1 is equal to 0. If 6w plus 7 equals 0, that means that w is negative 7/6. If w plus 1 is 0, then w turns out to be negative 1. So we have two proposed solutions. Recall that we found that -2 and -1 were restricted values that we're not allowed to use as our solutions. Comparing our proposed solutions, -7/6 and -1, to our restricted values, we see that -1 is not allowed to be a solution. So the only solution is going to be -7/6. I hope you found this video helpful. If you did, please remember to give it a thumbs up. That helps other students to find the video.